Everyone? Okay. Yeah. Good afternoon, everyone. I'm Max de Rooij. I'm a PhD student in the Department of Biomedical Engineering in Eindhoven University of Technology and Eindhoven Artificial Intelligence Systems Institute. And I will tell you about my recent work with SciML about personalizing models of human blood sugar using SciML. All right, so first we'll start with some relevance of the project. So the Netherlands, you might know it from cheese and tulips. The Netherlands also has a lot of pre-diabetes. So it's about 1.4 million people, which is 7% of the Dutch population, is estimated have pre-diabetes, which is a stadium that precedes type 2 diabetes and is characterized by elevated blood sugar, and also is correlated with a lot of health problems that occur and have a significant burden to the healthcare system. And one of these things is they have a 9 times higher risk of developing type 2 diabetes. So what we want to do about this is, we want to enable the personalized treatment of prediabetes, but for that we need to measure how healthy someone is. And one of these things, measuring health, is difficult. So it's very difficult to quantify how healthy someone is, directly. Another thing is that the development of prediabetes and type 2 diabetes is very slow and is also very heterogeneous. So every person can have a different trajectory in how they develop bad control over their blood sugar. Also, the effectivity of the interventions is really determined by how fast it's detected and how fast the intervention is applied, really. So one of these things that we want to try and do is to measure this health by measuring the state of the glycemic control, so the control of your blood sugar in the human. And we want to do this using a model. And the idea of the data that we use to quantify this is that someone consumes a liquid test meal. In this case, it's what we call an oral glucose tolerance test, which is just water with a lot of sugar. And we measure the blood sugar profile over time after someone has consumed this meal. And using a model, we can then quantify the status of someone's glycemic control system. And I said model, so what kind of model do I mean? So one of these models is developed here about 8 years ago, which is the Eindhoven Diabetes Simulator, or Eindhoven Diabetes Education Simulator, it's also called, but here we're not using it in education context, so that's why I left it out. And this model is a differential equation model that describes the uptake and actual release of glucose and insulin in the human body, and after one of these test meals. And using this model and the data, we can perform parameter estimation, and these parameters are then able to quantify someone's health in a personalized health space. All right, so this is very nice, but these models also have some trouble with some people, especially like in this case where we try to estimate the parameters. If the model shows this type of curve for someone, then we're not sure whether these parameters can actually quantify someone's health very well. So, and one of the reasons that this happens is because the model currently uses a PD-controlled insulin production term. So this is a term from more control engineering that also works in a thermostat, for example, to control the temperature in your house. And while it works very well on some people, it also gives results in these types of behaviors. And to mitigate this, my research was about how can we improve this personalizability. And one of the things that I tried was to include a neural network as this production term. So we model insulin production using a neural network, and to improve the personalizability of this model. So, all right, this is a nice goal, but we first also want to know whether these neural networks can describe a biological system properly with quite a low amount of data, because usually these measurements have like 4 time points. So it's quite difficult also to make sure to see if they work. So first, what we did is we did some tests. So we made a universal differential equation of a different system. This system is basically a substrate S and a product P that's converted, so the substrate is converted into the product using a specific type of kinetics, which we call Michaelis-Menten kinetics, which is also the term that is replaced by this N in the model equations below. And then using quite sparse data, we try to fit this neural network model to this data. And then as a result, you can see on your left, or on your right here, that it kind of works while we have data. So the gray area represents the area where we actually have data for this system. But afterwards, these models go crazy. So what you can see that while the blue one goes down and the red one goes up, you can see that somehow it is encoded in the system that there's a conversion between the two. But it's not captured very well to this system. So we also wanted to solve this, and by that we added an extra term to our loss function. So we regularized this system by kind of preventing the system from going below 0. And you can see that only adding this loss function actually quite improves the model fit also beyond the data. So this is one of the results. And then, all right, so as I promised you, we also tried to do this on our insulin production. And we actually see that within this model, while we have some neural networks that learn a kind of a biased term there, which is indicated by this gray constant line, we also have quite some neural networks that describe the insulin data very well. And the glucose data is also described very well on average. However, I was talking about personalized models, and this is actually on an average data of a population. It's also quite a lot of data here. So, well, for that, I'm going to leave you in the dark because I have not a lot to show on that part. So it's still ongoing work there. So we show that it works. We can actually fit these models quite well on sparse data. And this regularization can improve the reliability of these neural network representations. And in population data, these neural networks can estimate the insulin production term. However, for future work, we want to add multiple populations, see if we can estimate this in different populations, and we can personalize these models. Another area of research that we are looking at is to reparameterize these neural networks and use symbolic regression to actually get interpretable equations. This has become quite a challenge there as well. And the last part is to validate also these model predictions in multiple data sets. With that, I want to thank my supervisors, Natal van Riel and Shauna O'Donovan. And if you have any questions, I'd be happy to answer them.
Hello. With regards to type 1 diabetes, do you see any application in terms of predicting blood glucose levels to then apply insulin?
Yeah, good question. So type 1 diabetes is a bit of a more difficult case for these models, because on one hand, it's very difficult to predict how someone responds to insulin directly, because the insulin sensitivity can still vary between people, but because there's no insulin production or limited insulin production, it's also very difficult to quantify how much glucose is taken up in response to insulin, because you cannot. If someone is living with type 1 diabetes, you typically don't want to give them a test meal with 75 grams of sugar. So it's also kind of difficult to get these measurements, and also because there are a lot of different types of exogenous insulin that also kind of work in different ways. There is quite a lot to be done in that area to actually be able to quantify that. So I'm not actually actively working on that. We do have colleagues that work on type 1 diabetes specifically. So I can refer to them if you are very interested.
Thank you.
Well, thanks for your talk. It was really interesting. I saw you had very few data points. So I guess that you weren't measuring with the patches. There are some patches, I think, that measure also the glucose level, but a bit more in an imprecise way, I think. Are the results different if you measure it like this with more data points or like you're doing now?
Yeah, so on one hand, we for these models, we also need data on insulin, and unfortunately, we don't have these patches that can measure insulin yet. Nevertheless, if we would have them, that would be really nice. But also, we note we have done some research on these patches, basically on these flash glucose monitoring or continuous glucose monitoring sensors. Because they are also measuring glucose in a different part of the body, we also see that the response to a meal is different from when we measure it in the blood directly. So we'll need some conversion there as well.
Okay, thanks.